the IEEE standard 1366 of 2012, electrical power distribution reliability indices. Since the typical distribution system accounts for 40% of the total cost to deliver power and 80% of customer reliability problems, distribution system design and operation is critical for the financial success of the utility company and customer satisfaction. Interruptions can be analyzed through the use of reliability indices that should concern both duration and the frequency of outage. Hello everyone, my name is Rafael. I'm an electrical engineer, and in this video I'd like to speak with you about the IEEE standard 1366 of 2012, electrical power distribution reliability indices. And to do so, I chose this exercise. Let me read the problem. Assume that a utility company has a small distribution system for which the information is given in the table. Assume that the duration of interruption is the same as the restoration time. Determine the following reliability indices: SAIFI, CAIFI, SAIDI, CAIDI, ASAI, ASAIDI, ENS, AENS, ACCI. Okay, let's go. Let's calculate what the problem wants us to calculate. First of all, let's calculate SAIFI. SAIFI is the System Average Interruption Frequency Index, and it provides information about the average frequency of sustained interruptions per customer over an area. So how do we calculate the SAIFI? SAIFI can be calculated as the total number of customer interruptions divided by the total number of customers served. Okay? And the expression that we are going to use is this: SAIFI is going to be equal to the summation of Ni divided by Nt. And this is going to be equal to, where is Ni? Total number of customer interruptions. And this is this column here. We sum this with this, with this. This is the summation. We sum these values here and we find 950. And we divide by the total number of customers served. It is going to be equal to this plus this plus this plus this. We sum this column here and we find 1,000. And this is equal to 0.95. Okay? So the SAIFI is equal to 0.95 interruptions per customer served. 0.95 interruptions per customer served. Okay, so this is the SAIFI, letter A. Now let's move on to letter B. We are going to move on to letter B to calculate the CAIFI. It is not hard, okay? This is going to be a simple exercise just to get you ready for your exam. I know that some of you guys that have subscribed to my channel study electrical engineering university, and just to get you ready for your exam, okay, a simple exercise, letter B, CAIFI. And the customer average interruption frequency index provides information about the average frequency of sustained interruptions for those customers experiencing interruptions. So it's going to be the total number of customer interruption divided by the total number of distinct, okay, distinct. We are not going to count repetitions. It's distinct customer interrupted. The total number of customer interruption divided by the total number of distinct, very important, distinct customer interrupted. And according to the table, the CAIFI is going to be equal to the summation of NI. Once again, the customers that experienced the interruptions divided by CN. And the problem said that the total number of distinct customers affected is 700. So it's going to be equal to 950 divided by 700, which is 1.37. All right, very good, very nice. So the CAIFI is going to be equal to 1.37 interruptions per customer affected. You see the difference between SAIFI and the CAIFI. SAIFI is for everybody, the total number of people in that concession area, in that utility service area. But CAIFI is not for everybody. CAIFI counts only the affected customers, because you can distinguish them for Your SAIFI can be good. Your SAIFI can be good because you have a large area and you are experiencing a small number of interruptions. But your CAIFI can be bad because in one given specific area there is going to be many outages, many interruptions. Then that's why maybe you have a good SAIFI but a bad CAIFI. And here we discovered that the CAIFI is larger than the SAIFI because there is one area that is experiencing more interruptions than the average. Let's go to SAIDI, my favorite. Do you have a favorite index? SAIDI is my favorite. And it is very easy to calculate the SAIDI. It's very easy to calculate the SAIDI. What is the SAIDI then? SAIDI is the System Average Interruption Duration Index, and it provides information about the average time the customers are interrupted. So it's the sum of customers interruption, durations, and we divide it all by the total number of customers in the utility service area. Okay? Total number of customers in the utility service area. And here, the sum of customer interrupted durations, we multiply Ri, we multiply the durations, this column here, 2 hours, 3 hours, 1 hour, 1 hour, and with the number of customers here. So, this part here is going to be SAIDI is going to be equal to the summation of the product between Ri, the durations, and Ni, the customers affected, divided by Nt. Here, you need to pay attention on this, okay? You need to pay attention on this. You have to do the following. Multiply 250 with 2, multiply 200 with 3, multiply 250 with 1, multiply 250 with 1. You sum the results, and then you're gonna get this. You're gonna get 1,600, and you're going to divide it by 1,000. 1,000 because we got 1,000 customers. And then our SAIDI is going to be equal to 1.6 hours per customer served. Okay? 1.6 hours per customer served. This is our SAIDI. Alright? Are you guys understanding everything? Now let's move ahead to the others. Very simple exercise, okay? It is not difficult, I must warn you, it is not difficult. If you are having difficulties, simply play the video again. Okay, let's calculate now the CAIDI, letter D, the CAIDI. The CAIDI, letter D, CAIDI. CAIDI is the sum of customer interruption durations, and we are going to divide by the total number of customer interruptions. Okay? Are you guys understanding everything? And then we can find the CAIDI as the summation between the product of I and NI, the product between RI and NI, divided by the summation of NI. And this, we have a shortcut to this, okay? There is a shortcut to this. If you have already calculated SAIFI and SAIDI, we can find that it is the product between SAIDI and SAIFI. And then we find that it is 1.684 hours per customer interrupted. Okay? We have calculated SAIFI and we have calculated SAIDI. You simply divide one by the other and then you find the result. Very simple. Are you guys understanding everything? If you are having difficulty, play the video again. Do as I did when I was studying. I used to play the same video many times to understand. Alright, let's go to letter E. Letter E is ASAI. I know that you guys are studying electrical engineering. I have subscribers from India, I have subscribers from Asia and Africa. And they talk to me via WhatsApp. If you want to talk to me using WhatsApp, I'm going to leave my number and then you give me your problem. And then I will make a video about it, about your doubt. Okay, ASAI is the average service availability index, and it represents the fraction of time that a customer has power provided during a period of time. Okay, ASAI is going to be equal to customer hours of service availability And we are going to divide it by customer hours service demand. Okay? And to calculate this, we use this expression here. Don't get scared. It looks difficult, but it is not. ASAI is going to be equal to NT times hours in a year minus the summation of RI times NI. NT times the number of hours in a year minus the summation of RI times NI divided by NT times hours per year. Okay. What is this number here? Do you guys have any idea what this number is? It is simply 8,760. 8,760. And we simply use this number here. Okay? NT times 8,760 minus the summation of RI times NI, NT times 8,760. And then we use the values that we were provided here, and then we find that NT is 1,000 times 8,760 minus. Do you remember how to find this number? Simply multiply this with this and sum with the multiplication between this and sum with the multiplication between this and so forth, and then you find this. And then you divide it all by 1,000 times 8,760, and then we find 0.99982. Okay? It is not hard. Don't get scared by the expression. It looks difficult, but it is easy. Oh, let's move ahead then. ASAIDI what is ASAIDI? ASAIDI is the average system interruption duration index, and it provides information on system average duration of interruption. So ASAIDI is going to be equal to the connected load, the connected demand in kVA, duration interrupted, and we divide it all by the total connected load, or the total connected demand in kVA served. All right. Oh, hello, my friends. Let's continue. Somebody called me and I had to cut the video. We were speaking about the ASAIDI, And how do we calculate the ASAIDI? We simply multiply the durations of the interruptions with the load interrupted, Li, and then the loads are here and the durations are there. We simply multiply this number with this number, and then we sum with the multiplication between this number and this number, and then we sum with the multiplication between this number and this number, and we divide by the total load, which is 10,100, and then we simply do this: 15,300 divided by 10,100, and then we find 1.515. Okay? Is everything alright? Are you guys understanding everything? Okay, now let's calculate one index that I find to be very important, which is the AENS. Okay, guys? If you guys are not understanding everything that I'm saying here, you can contact me using my WhatsApp number, or simply leave me a message in the comments of this video. Okay? My WhatsApp number is going to be there. Alright, the AENS. The AENS is the energy not supplied index, and it represents the total energy not supplied by the system. Okay? It is going to be equal to the summation of the average individual loads times Ri. Ri is the duration. And then we do this, this, and this, and this, and then we find the value of 15,300 kilowatt hour, or 15.3 megawatt hour. Alright, very good people, very good. Now we are going to move on to calculate the AENS, which is letter H. Okay? The AENS is the average energy not supplied. AENS, which is going to be equal to the total energy not supplied divided by the total number of customers served. Okay? And the expression for AENS is going to be equal to the summation of the average loads, average individual loads, the product with Ri divided by NT, and there is a shortcut to this, which is AENS NT, which is going to be equal to 15,300 divided by 1,000, and this, as you can see, AENS is equal to 15.3 kilowatt hour divided by customer affected. Okay? Are you guys understanding everything? If not, contact me. Okay, and the last one, the last index that we are going to calculate is the ACCI. The ACCI, what is the ACCI? Let's see what is the ACCI. Is the average customer curtailment index, and it represents the total energy not supplied per affected customer by the system. So the ACCI is equal to the total total energy not supplied divided by the total number of customer affected. And this is going to be similar to the others, in which you're going to have to calculate the summation of the individual average loads and multiply it by the duration of the outage, RI, and divide it by Cn. And the problem said that the distinct customer affected is 700, then it's going to be equal to 15,300 divided by 700, which you can notice is equal to AENS divided by Cn. Okay? Very easy. Alright. And then we find finally that ACCI is equal to 21.85 kilowatt hours divided by customer affected. Okay, my friends, this was the video that I wanted to make. I hope you guys enjoyed and understood it all. If you want to contact me, use my WhatsApp number. Goodbye!